Hello, my name is Ping Wan. My pronoun is they, them. I'm from University of Illinois, Chicago, and I'm going to talk about quasiconvex subgroups of acylindrically hyperbolic groups in this talk. So let's start with hyperbolic groups. We say a group G is hyperbolic if for some finite subset x of G, the Kelly graph of G with respect to x is connected and delta hyperbolic for some delta. Now, a space is delta hyperbolic if every geodesic triangle in that space is delta slim. That is, if we look at any two sides of this triangle and we look at the delta neighborhood of these two sides, this third side should be contained in this neighborhood. So that's the delta slim triangle. An example here is a rank 2 free groups. So this rank 2 free groups could be generated by two generators. So that's the finite generating set. And the Kelly graph is an infinite tree, so it's connected and contains no loop, which means any triangle in this tree looks like this. So this is a zero slim triangle. Since the Kelly graph is connected and zero hyperbolic, the rank 2 free group is a hyperbolic group. Now, in a hyperbolic group, we say a subgroup H is quasi-convex if the inclusion map is a quasi-isometric embedding. So quasi-isometric embedding means the metric on the subgroup is not distorted too much. An example here is the subgroup Z. So if we look at the subgroup Z generated by the generator A here, it's going to be a line extending on both sides infinitely. So as you can see, the inclusion map here does not distort the metric on this line at all. So that's a nice quasi-isometric embedding, which shows subgroup Z is a quasi-convex subgroup of rank 2 free group. Now, acylindrically hyperbolic groups generate hyperbolic groups, and it's a very broad and very interesting groups, including most of the mapping class groups of finite types spaces, surfaces, and it could also including automorphisms of free groups, and many other interesting groups. So from now on, I'm going to assume my group G is finitely generated. And a group G is acylindrically hyperbolic if for some set x of G, note that we do not require x to be finite now, and some finite collection P of infinite subgroups, the cone of Kelly graph G along P with respect to x is connected hyperbolic and fine at converges. So a cone of Kelly graph is shown as is something constructed on top of Kelly graph. So on the right hand side, I have an example of cone of Kelly graph. Here, the Z plus Z is generated by two generators again, and the grid here is the Kelly graph of Z plus Z. On top of it, I'm adding some more vertices and edges in this way. So I'm choosing this Z as my P here, and I'm adding one cone vertices corresponding to this Z, and I'm connecting this cone vertices to any vertex inside Z. So that's how I cone off Z, and I do this for every copy of Z inside Z plus Z to get a cone off K graph of Z plus Z along Z. Okay, so that's a cone off K graph. And another new word here is fine at cone vertices. Fine is a local finiteness condition. It means that at this vertex, for every finite number n, there are only finite many loop that contains that vertex with length n. So as you can see here, there are infinite many triangles containing this vertex, right? Containing this cone vertices. So this means this graph is not fine. And so it cannot be used to show Z plus Z is acylindrically hyperbolic. So that's a non-example. Now, my research is to give a notion of quasi-convex subgroups inside a cylindrical hyperbolic group. And naturally, I'd like to use the quasi-isometric embedding. So I defined a subgroup H to be GP quasi-convex if there exists a compatible compatible collection of subgroups of H such that the extension of inclusion, so the extension of the inclusion of H in G, extend it to the cone of Kelly graph. So this extension of inclusion is a quasi-isometric embedding. Now, if I stop just here, that's just the definition. So now I'm going to show you some application of this definition. Dam filling is a very strong tool, powerful tool in relatively hyperbolic groups and hyperbolic groups. So basically, I start with a group G and I start with a collection of subgroups P. And then I choose for every P lambda inside the collection of P, I choose a normal subgroup N lambda. And then I let K be the normal closure of all such N lambdas in G. So now I do the quotient, and then I let G bar be G quotient by K. That's going to be my filling. Similarly, I could do the quotient on any subgroup P lambda, just quotient by N lambda, and I get a P bar lambda. I can do that because N lambda is a normal subgroup. Okay, so that gives me a G bar, P bar. So to start with, if G is a cylindrical hyperbolic group, and I do a nice enough filling, then G bar is going to be a cylindrical hyperbolic group again. So that's a theorem by Osin, Damani, and Guihardel. Now, I show that suppose H is a GP quasi-convex subgroup. Then for sufficiently long H fillings, that is for some nice fillings of G with kernel K, the induced filling on H, that is, I'm quotienting since I'm quotienting since that it both in H and K has kernel KH, that is just K intersect H. So the induced filling does not contain anything more. Moreover, if I let H bar be H quotient by this filling kernel of itself, H bar is again a quasi-convex subgroup in G bar with respect to P bar. So that ensures that like for nice fillings, after quotienting, I still have this quasi-convexity. Another application is generalizing a theorem in relative hyperbolic group. So if G acts co-compactly on a cat zero cube complex, and with some extra nice conditions, in these nice conditions in particular, I'm requiring self-stabilizers to be full GP quasi-convex. So then for nice enough fillings, with some extra nice conditions, the quotient X by the kernel K is again a cat zero cube complex. So we start with G acting on a cat zero cube complex. After quotienting a nice filling with some nice properties, I again get G bar acting on X bar, and this X bar is the cat zero cube complex. So you can see that's the flavor of a strong flavor of dam filling. So that's all of my talk. Thank you for listening, and thanks the organizers for organizing this meeting.